For section 3.1, integer exponents, we're going to simplify expressions that have integer exponents. So to do this, we're going to use 4 different things. We're going to use 0 as an exponent, negative exponents, product rule, which is multiplication, and quotient rule, which is division. When we do this, we're going to look for and express regularity in repeated reasoning. That's talking about patterns, and we're going to use a lot of patterns in this section to figure out what's really going on. So we're actually going to start off with a pattern, but before we do that, I have just a little bit of story to tell you. I need a little space here to draw. So back when I was in college, I did not work enough at a high enough paying job to afford my rent and my bills all the time. And I was living in an apartment. And so here's my apartment building, and I'm living up here on the top floor. My apartment's owned by this one company, and I couldn't pay my rent, and so I got evicted. So I had to move out, and of course I'm not very happy about that. I didn't want to move because I really liked where I was, and I liked the location, and it was all just great. So I ended up discovering that the apartment below mine, so on the floor below, was owned by a different company. And I was able to get approved, and they let me move in to an apartment down there. So once I moved, I didn't have to move out of that building. I just had to throw my stuff down the stairs and into a new apartment. Of course, I'm super happy about this. So once I moved downstairs, I'm super happy. Well, numbers are actually the same way as my little predicament I was in when I was in college. If I have the number 2 to the negative third, that negative exponent is kind of like an eviction notice. And so when that negative exponent's there, it's telling it that it needs to move down to the basement. And so this 2 to the negative third needs to move down to the basement. And when it does that, that negative becomes a positive. It goes from being really upset to being happy. So it's now a positive 2 thirds, and there's just one empty apartment upstairs. So that's what we're going to use as we go through. That's actually one of the rules that we're going to learn. So I'm just going to take this little drawing and throw it over here to the side. All right. So for this pattern, we're going to start with 3 to the 4th power. Well, 3 to the 4th power is 3 times 3 times 3 times 3. Well, I know 3 times 3 is 9. And I know that 9 times 9 is 81. So I know that 3 to the 4th is 81. Well, next, moving down, 3 to the 3rd, well, I'm going to take away a 3, and now I have 3 times 3 times 3, which is 27. So what I did here is I divided a 3 out of there, and 81 divided by 27 is actually 3. Or 81 divided by 3 is actually 27. So I'm going to continue this. If I divide by 3, well, 27 divided by 3 is 9, and I know that 3 squared is 9. And so this pattern seems to be working. So I'm going to divide by 3 again. 9 divided by 3 is 3. Well, I know 3 to the 1st is 3. So I'm going to keep going. I'm going to do 3 to the 1st divided by 3. So 3 divided by 3 is 1. So if I'm following this pattern, that tells me that 3 to the 0 power is 1. Well, if I think back to the plant activity that we did a few days before, when we were in month 0, so the month that we bought the plant, its height was 1. So if 2 to the 0 equals 1, and if 3 to the 0 equals 1, that pattern tells me that anything to the 0 power is 1. So I'm going to go back to my pattern, and I'm going to continue this on. And so I'm going to take my, I'm going to go down one more spot, and I'm going to divide by 3 again. Well, 1 divided by 3, that's just 1/3, because I know division and fraction are the same thing. And then I'm going to go another step. I'm going to divide by 3 again. Well, 1/3 divided by 3, I'm dividing fractions, so I need to write this as 3 over 1. I'm going to keep, change, and then flip. And so I see that this is equal to 1/9. Well, one thing I want to notice is that 9 is 3 squared, so 1/9 is 1 over 3 squared. Notice this, 3 to the negative second is equal to 1 over 3 to the second. So that negative exponent made 3 to the second move down to the basement, move down to the denominator, and then it became positive. If I were to look back at 3 to the negative first, 1 over 3 is just 1 over 3 to the first. I can write it that way. So 3 to the negative first is equal to 1 over 3 to the first. Now I'm going to continue on with my pattern. I'm going to divide by 3 one more time. 1/9 divided by 3, I can work that out, but I'll tell you that that's 1 over 27. Well, I know 27 is 3 to the third, so 1 over 27 is 1 over 3 to the third. Once again, 3 to the negative third is equal to 1 over 3 to the third. I'm going to go one more step. I'm going to divide by 3 again, and I get 1 over 81. Well, I know 81 is 3 to the fourth, so 1 over 81 is 1 over 3 to the fourth. And once again, 3 to the fourth, 3 to the negative fourth is equal to 1 over 3 to the fourth. So we can conclude from this that anything to a negative power is the inverse. If we look at this pattern, we see that it's creating fractions, but the thing that's special about those fractions is their inverses. 3 to the negative first, if I'm not paying attention to that negative, 3 to the first and 1 over 3 to the first is an inverse. 3 squared and 1 over 3 squared is an inverse. It's the number flipped into a fraction. Another way to think about this, and this might work for some of you and maybe not as much for others, is that negative means opposite, right? Negative means opposite. And then we know that exponent means repeated multiplication. So if we put those two things together, a negative exponent would be the opposite of repeated multiplication, so it's repeated division. So if I look over here, a fraction is the same as division, so 1 over 3 to the fourth is actually 1 over 3 times 3 times 3 times 3. That's repeated division. One thing that I want to make sure is really clear is that a negative exponent does not make the value of a number negative. It does not make it negative. A negative exponent is the inverse. I'm now using the word inverse in place of reciprocal. But when I say inverse, I'm talking about reciprocals. This is the inverse of the positive exponent. So when we were looking at the inverses just a minute ago, I said we're not paying attention to the negative in the exponent. That's just because the negative in the exponent tells us to take the inverse of the positive exponent. So we're going to go through some examples of this, but I just want to make sure before we do this that we have some common terms. So when I have something like 2 to the 7th, when I'm talking about the 2, so the big number, I'm talking about the base. And then when I'm talking about the 7, I'm talking about the exponent. So now let's do some examples. First I have 8 to the 3rd. Well, 8 to the 3rd is repeated multiplication. It's just 8 times 8 times 8, which is 512. If I move over to the other side of this table, it says I choose whether this is positive or negative. This is a positive number, and it's positive because the base is positive. Next, I'm going to come over to 5 to the negative 3rd. First thing I notice is that I have a negative exponent. And so that negative exponent tells me that that's an eviction notice and it needs to move. So it needs to move down to the denominator, and when it does that, it becomes positive. So now I have 1 over 5 to the 3rd, which is 1 over 125. So this is positive, and it's positive because the base is positive. And then the other thing I want to think about is this less than 1 or greater than 1? So if I think about 1 over 125, that number is less than 1. And it's less than 1 because the exponent is negative. So the exponent makes this number less than 1. So the next two problems I have are pretty similar. The only difference is there's a parentheses in one and there's not a parentheses in the other. So this first one, I have negative 4 in parentheses to the negative 2nd power. Well, the first thing I notice, I have a negative exponent, which tells me that this is going to create a fraction. I'm going to take the inverse of it. But I need to think about what the exponent is affecting. And it's touching the parentheses. So that tells me that it's affecting everything inside the parentheses. I call this a nice exponent. This is a nice exponent because it includes everyone. So when they move, everyone gets to move together. So the negative and the 4 moves together, and then the negative 2 as an exponent becomes a positive 2. And I just have 1 left in the numerator. And now when I multiply this out, I have the quantity of negative 4 squared. Well, that 2 as an exponent is still a friendly exponent. So this is actually 1 over negative 4 times negative 4, which is positive 16. So I have 1 over positive 16. So this answer is positive. And it's positive not because the base is positive, but because the negative is included in the base. Now, is this less than 1 or greater than 1? Well, this one is less than 1, and that's because the exponent is negative. All right, moving on to the next one. I have negative 4 to the negative 2. Negative 4 to the negative 2nd power. Well, I have a negative exponent, so that tells me that this is going to create an inverse. I'm going to take the inverse of negative 4 to the second. But I need to think, is the negative included in this or not? Well, this is a mean exponent because it's only touching the 4. It's not including the negative in front. So it's mean. So that means that the 4 is going to move. And that exponent's going to become positive. And the negative is now hanging out by himself. And now when I multiply this out, I have negative 1 over 16. So this one is negative. And it's negative because the negative is not included in the base. So as you can see, it's really important to make sure you pay attention to your negatives. Make sure you pay attention to where the negatives are. Make sure you pay attention to the nice and mean exponents so that you make sure your answers are positive or negative as they need to be. Now, before we do some more problems together, I want to talk about multiplication and division with exponents. So when you multiply and divide numbers with exponents, it's super, super, super important that you only combine numbers with the same base. They have to have that same base number or same base variable in order to multiply them or divide them. Now, when you're multiplying with exponents, you're going to multiply. So when you're multiplying numbers with the same base, remember they have to have the same base. It's weird, but you're actually going to add the exponents. So when you're multiplying numbers with the same base, you're just going to add the exponents. So let's see what this looks like. This first problem, I have 3 squared times 3 to the 9th. Well, 3 squared is 3 times 3. And 3 to the 9th is 3 times 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 3. And those are being multiplied. So altogether, if I count them up, I have 11 3's being multiplied. So this is 3 to the 11th. So what I did is I took 2 plus 9 to get 11. Let's do another one. 5 squared times 5 to the 10th. Well, 2 plus 10 is 12, so I have 5 to the 12th. Let's double check that that's right. 5 squared is 5 times 5. 5 to the 10th is 5 times 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 5. If I multiply those together, I get 12. So I have 5 to the 12th. That's the same process for all these other problems. So this one, 4 to the 8th times 4 to the negative 6th. I can do this without writing those all out, and I'm going to start doing that because that's a lot of extra work to write that out. So I have 8 plus negative 6 because I'm multiplying numbers with the same base. So I'm adding the exponents. 8 plus negative 6 is 2. So this is 4 squared, or 4 to the 2nd power. Moving down to the second line, I have 7 to the negative 3rd times 7 to the negative 2nd. I need to be really careful with my negatives here. I'm multiplying numbers with the same base, so I'm going to add the exponents. I have negative 3 plus negative 2, and that's equal to negative 5. So I have 7 to the negative 5th. Now, one really important piece of information for you is that you cannot leave your answers with negative exponents. So 7 to the negative 5th, that's a negative exponent, and so I need to go another step to get rid of that negative. To do that, I need to take the inverse of the positive, so this becomes 1 over 7 to the 5th. The next problem, I have b squared times b to the 4th. Even though I have variables in this, I'm going to treat it exactly the same as I would any other problem. I still have the same base, I have the same variable for the base. So I'm just going to add my exponents. 2 plus 4 is equal to 6. So this answer is just b to the 6th. Now this next problem, I have a to the first times b to the 0. Well, a and b are not the same base, so I cannot combine those. And typically I would just leave this alone, but I can actually simplify this a little bit. A to the first, well, I can just write that as a. And then b to the 0 power, well, anything to the 0 is 1. So that's 1. And then I know that a times 1 is a. So that actually just simplifies down to a. So that's everything for multiplying with exponents. Remember, when you multiply numbers with the same base, you add the exponents. Make sure when you're adding the exponents that you write it out, just like I was doing on all of these, because there's so many negatives. It's really easy to lose track. So make sure you're just writing that out. It takes just a couple seconds to do that, and it makes a big difference sometimes. So once again, when we multiply numbers with the same base, we add the exponents. So now we're going to divide numbers that have the same base. So when we multiplied, we added. So when we are dividing, we're going to do the opposite. Since multiplication and division are opposite, we're going to do the opposite of adding. So we are going to subtract the exponents. So when dividing numbers with the same base, subtract the exponents. So for this first one, first of all, let's see what's happening here. I have 8 to the 9th over 8 squared. So 8 to the 9th would be 8 times 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 8 over 8 squared, so I have 8 times 8. Well, my 8 over 8 and my 8 over 8 cancel out. They just cancel to 1. And I'm left with 7 eighths in my numerator. So this is 8 to the 7th. 9 minus 2 is 7. So since I had the same base, I could have subtracted my exponents to get 7. Let's go ahead and do another one. 7 to the 3rd over 7 squared. That would be 7 times 7 times 7 over 7 times 7. Well, those 7's cancel out, and I'm just left with 7 to the 1st, which is just 7. I could have done 3 minus 2 to get 1. Next one, 5 squared over 5 to the 9th. If I'm just going to subtract those, since I have the same base, I'm going to do 2 minus 9. So I'm going to add the opposite. And so this equals negative 7. So I have 5 to the negative 7th. I can't leave a negative exponent, so I need to write this as 1 over 5 to the 7th. Remember that negative exponent tells me to take the inverse of the opposite, so I'm going to write it as a fraction. Now that's kind of weird. That was a little bit of a different one, so I am going to show you this one also. 5 squared is 5 times 5. 5 to the 9th is 5 times 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 5. Now these two cancel out, and I'm left with 7 5s down in my denominator. Here I have 7 5s down in my denominator. All right, moving on to the next row. I have 6 squared over 6 to the negative 2nd. So I'm going to do, I have the same base and I'm dividing. So that means I'm going to subtract my exponents. So I'm going to do 2 minus negative 2. I'm going to add the opposite. 2 plus 2 is 4. So this is 6 to the 4th. Next, I'm going to do 2 to the negative 12th divided by 2 to the negative 3rd. I'm dividing numbers with the same base, which means I'm subtracting the exponents. So I'm taking negative 12 minus negative 3. I'm going to leave change, and I end up with negative 9. So I get 2 to the negative 9th. I can't leave a negative exponent, so I need to take the inverse of the opposite, which means it needs to move to the denominator and become positive. I have just one left. I have w to the 31st over w. I'm going to subtract these since I have the same base. I have w for the base on both of these. Now w has an understood variable or understood exponent of 1. Whenever there's not an exponent, it's understood that it's 1. So I'm going to do 31 minus 1, which is 30. So this is w to the 30th. That's all for dividing with exponents. Remember, when you divide numbers with the same base, you subtract the exponents. There's just a couple more practice problems that we're going to do together, and then that will be it for this section. So this first practice problem, 3 to the third over 3 to the negative second. I notice that I'm dividing, and I have the same base, so I'm going to subtract my exponents. So I'm going to do 3 minus negative 2. I'm going to add the opposite to get 5. So this is 3 to the 5th. Now 3 to the 5th, if I were to multiply that out, that's going to be a positive number. And that's positive because the base is positive. And then that's going to end up being greater than 1. If I'm comparing less than 1 or greater than 1, it's greater than 1 because the exponent, once we did the division, is positive. All right, this next one is a little different. So this next one, I have m to the third into the negative second over m to the negative seventh into the fifth. There's a lot going on here. But we're going to break this up and we're going to take it piece by piece. Remember, when we're multiplying or dividing, and anytime we're combining numbers with exponents, they have to have the same base. So I can only combine numbers with the same base. So I'm going to focus on my numbers that have m for a base first. I'm dividing m to the third divided by m to the negative seventh, which means I'm going to subtract the exponents. So I'm going to take 3 minus negative 7. I'm going to add the opposite to get 10. So this is m to the 10th. Next, I'm going to focus on the n's. So I have n to the negative second over n to the fifth. I'm dividing numbers with the same base, so I'm subtracting the exponents. Negative 2 minus 5. I'm going to add the opposite. That's negative 7. So that's n to the negative 7th. But I have a negative exponent, so I need to change this negative exponent, but I need to keep this one the same. So what I'm going to do is this is multiplication. Now I have two variables next to each other, which tells me that it's multiplication. So I can leave m to the 10th as it is, and then I can change n to the negative 7th into the fraction. I can take the inverse of the positive exponent. So I can write this as 1 over n to the 7th. I'm multiplying fractions now, so I'm going to write this over 1. Now typically I cannot combine this stuff, but since I'm multiplying by 1, I can. So m to the 10th times 1 is just m to the 10th. And 1 times n to the 7th is just n to the 7th. And that would be my final answer, because I do want to write it as one fraction. So is this positive or negative? Well, m to the 10th over n to the 7th, I don't know. I don't know what those variables are. So this is actually unknown. And that's because they're variables, and I don't know what the variables are. Now the next one, 3 to the 9th times 3 to the negative 5th. I have multiplication, and I have the same base. So I'm going to add the exponents. 9 plus negative 5 is 4, so this is just 3 to the 4th, which I know is 81 off the top of my head because we did that earlier in these notes. I know that 81 is positive, and this problem is positive because the base is positive, because remember it was 3 to the 4th. And now is this less than 1 or greater than 1? Well, 81 is greater than 1. It's greater than 1 because the exponent is positive as well. It's a positive 4. Going on to the next problem, 3 to the negative 9th times 3 to the 5th. It's very similar. I'm multiplying with the same base, so I'm going to add the exponents. Negative 9 plus 5 is negative 4. So now I have 3 to the negative 4th. I have a negative exponent, so I cannot leave my answer like this. My negative exponent tells me I'm going to take the inverse. So I need to take this as 1 over 3 to the 4th, which I know 3 to the 4th is 81, so 1 over 3 to the 4th is 1 over 81. This is positive. It's positive because the base is positive. One over 81 is less than 1. It's less than 1 because the exponent is negative. So that turns it into that fraction. I just have one more problem left. X to the 10th times y to the negative 2nd times x to the negative 3rd times y to the negative 1st. There's a lot going on here. So let's just focus on one part at a time. I can only combine numbers that have the same base. So I can combine my x's, and I'm multiplying. So I'm going to add the exponents. So I can do 10 plus negative 3, which is 7. So I have x to the 7th and then I'm going to combine my y's. Y to the negative 2nd times y to the negative 1st. I have the same base, so I'm going to add my exponents. Negative 2 plus negative 1 is negative 3, so I have y to the negative 3rd. I cannot leave a negative in my answer, so I'm going to change this. Now I can go through that whole process that I did up here where I write them out and then I combine the fractions, and that's perfectly fine. If I do that, I would get x to the 7th times 1 over y to the 3rd, and I multiply that across to get x to the 7th over y to the 3rd. Or I can see this, and I can see that the y to the negative 3rd is going to have to move down to the denominator. And so I can imagine a denominator here, and I can imagine the y to the negative 3rd moving down. And when it moves, the negative exponent becomes positive. So this is going to be x to the 7th up in the numerator, and now y to the positive 3rd is in the denominator. Either way, you end up getting the same answer. So it does not matter which way you think about it. I don't know if this product is positive or negative because it's variables. So I'm going to put unknown because of variables. That is all for this section. So you can finish the 3.1 notes now. And of course, if you have any questions, come talk to me, come let me know.